Hi everyone, today I want to talk to you about using Tmax and other Unix philosophy tools to create your own intercept and act mechanism. This might sound very vague, but this is actually a relatively simple concept, and I'm excited to show you this architecture. So the best way to understand it is to try to understand the problem I am trying to solve. And this problem is generic enough that I thought it might be useful as a video. So the problem is reacting to specific text in a terminal pane. So there's plenty of examples where this could be useful. I have chosen one where I need it for my AI workflow, but you can have quite a lot of those. So the idea is very simple. You have a terminal pane, in my case, a Tmax pane, and you want to be able to detect any text, ideally based on regex pattern, and perform any action when this text appears. So that's the premise of the whole system. And the reason why I found it interesting and I wanted to share with you is that the architectural choices that I tried to make when building this system are following Unix philosophy and making otherwise distributed complex system simpler. So I hope you can learn a little bit about both Unix philosophy, building distributed systems, and at the end having something that can be useful for your workflow with just a few tweaks. So back to my case, reacting to terminal panes. When I work with Claude, I often have a few sessions. So in my case, Claude would work on a repository or a system, and I would tab out to another session and I would do something different. And then I would have to go back every now and then and see if Claude needs attention, whether I need to confirm a choice that it makes, creates a file or running a command, or it simply was running a long command and I am waiting for the output. This is not critical, but it's very nice to have. So if I want to be efficient, and watching my videos, you probably know that I really like efficiency, I would like to be able to react when I know that Claude needs my attention. So that was the first motivation for my problem. Then when this happens, I want to be able to quickly identify from which Tmax session the notification came, and more importantly, swap to it instantly. And finally, in my case, the acting on the information. So when I found a regex that I am looking for, the acting is going to be subtle notification. Let's call it like that. I will show you this all in practice in a demo in a while. But that's to set up the scene of what we are going to look at today. So if you think about it, this problem can be divided into three components. We have inputs, and the input from a terminal can have three forms. It's std_in, which is what I am getting on standard in, so what my terminal is getting as an input. Standard out, which is typically a PTY or output to a terminal, and standard error, which can be redirected anywhere, but also by default is being redirected to terminal. The basics of how file descriptors and processes work is outside of this video, but this is all the basics of how Linux and terminals work. So that's one kind of inputs we can have in a terminal pane, and the terminal events is another one. I am not utilizing those yet, but you could imagine reacting on creating a new Tmax pane or removing one or resizing a terminal window and so on. So this is one component, which is the inputs. The bindings, in my mind, one of the most important and elegant solutions of this particular architecture, the binding You can think of the bindings as the intermediary contract between inputs and outputs. Outputs, by the way, can be any executable, can be Python, Bash script, any program written in Go or any language, anything you want, you can execute. So this is very versatile and flexible. And we need to bind together the inputs and outputs by something. So from distributed systems theory, you might know things like queues or event systems. In Linux, this could be dbus, for example. In distributed systems, it could be things like Kafka or other queuing mechanisms. So those are things that bind the input and output. In my case, since I am using a single machine, I have elected to use file system as a binding, and you will see all this how it gets together in a demo. But the system components can be divided into inputs, bindings, and outputs. So let's look at the diagram, what is actually happening, and how this whole system comes together. So a Tmax pane produces an output. In my case, this is a Claude doing stuff, and typically either finishes something or asks me for confirmation. And I have looked at how Claude works, and I found that there are certain patterns I can apply regex to, and with a high degree of confidence I can rely on them, saying, okay, if this pattern happened, then I know that most likely Claude I need to confirm something, or it finished. So there is a script running and monitoring the pattern. Now, how this script is implemented, I will show this later, but it uses a Tmax feature called pane pipe. And pane pipe is really like a mirror of what happens in a pane. You can think about it as redirecting pane to a completely different process or to a file. So that's exactly what I'm utilizing to capture anything I'm typing in a pane. This all stays, of course, in the local boundaries of my system. It's not going anywhere. And I'm tracking this output in regex. Once the pattern is detected, I am creating a file. Remember, the bindings between my inputs and outputs, which is executable, is a file. So I treat a file system as a queuing mechanism. I create a file that adheres to specific naming convention, and this file is then observed by another system. In my case, the system is called Argos. Argos is very specific to Linux and specifically to GNOME. So this is just a really cool program that enables you to create your own GNOME extensions. And the reason why I chose Argos and GNOME extensions in first place is that I don't really want to have notification appearing randomly, but rather I want to have this traffic light style notification. You can see here on the right corner we have this little green light with an icon of a brain. I didn't know what else to put here. But as long as this is green, that means that Claude in this case doesn't want anything from me. No pattern was detected. The moment when this switches to red, and there's also numbers here, then I know that in some session Claude either finished or it needs my attention. So that's Argos. Again, Argos is outside of the topic of this video. I might do the video about it. It's a really interesting program if you're using GNOME. I am sure there are other equivalents. There's an equivalent for Mac, and I'm sure there's similar equivalent for KDE or other desktop environments. All right, so Argos simply is relying on the files that are being created every time there is a notification detected. Notification detected means new file. And Argos is programmed to observe those files according to certain naming convention and simply display notification. And now the last piece of the puzzle is a key binding. I have a script that essentially goes through all those files And those files, by name, they contain all the coordinates to my Tmax session. So session name, window, and pane. And they also have a timestamp. And by cycling with my key binding in this case, I cycle through all the sessions that have the notifications. The moment I do this, the file is deleted. This means the queue element, the element from a queue is emptied. So again, the system behaves as a distributed system that relies on a queuing mechanism. Okay, I realized that was a lot to take without looking at any code or demo. So bear with me, we're almost there. So one thing to highlight again, Unix philosophy. In Unix and Linux, everything is a file. Literally everything is a file, and it has a file descriptor and so on. So I'm basing on this and choosing files as a queuing mechanisms. This enables me to perform atomic operations on queues. There's no race conditions because it's a FIFO queue. So first in, first out. And also my system can be completely distributed because I have components of my system, which in my case are various scripts, distributed. I could imagine porting the system to work on things like Kubernetes or servers. This could be, of course, complete overkill for this particular problem, but it's doable. The principles of architecting the system are the same. Okay, so now we are ready to switch to the demo. So let me see. I have here some music, and here is my demo. So first, I'm going to show you the code. So here I have my projects. This is probably another video idea, but those are essentially, you can see here those various files. Let me open all of them. You can see this comment project AI. I essentially have automation that detects files that have this comment project AI. And here also I have it like that. So this is, again, related to what you see, but not necessarily to the topic we are discussing. I will make a video about this. It's a very convenient way of associating together distributed files from various folders. Anyway, let's look at the code briefly. So this is just a wrapper code that instantiates, in my case, Claude, wrapping it in the monitoring script. So this is very simple. As you can see, it references the monitoring script itself, has some defensive programming, and at the end launches Claude with any parameters that I want to do. Okay, so this script is the core of the whole system. So it has 146 lines of code. A lot of this is helpers and variables, but this script is essentially responsible for monitoring the Tmax session itself. So for example, you can see here that we can do tail F on line 59. So we are monitoring the Tmax pane pipe command. And at the end, we are detecting various things. So here is a line that starts with this kind of a dot Unicode character. That tells me that Claude finished something. Every time this appears, that means that Claude is done and finished it. And I have also another pattern when it asks me for confirmation. So here on this line, you can see, do you want to, and then followed by this Unicode character. So this is the way how I'm detecting that Claude needs my attention. And then at the end, there's logic here that allows me to use my script and read the files I mentioned earlier and navigate to a Tmax session that is correct. There's a few caveats here. For instance, I don't want to have notification if I am in the same window. So if I would be running Claude, let's say, in another pane, I don't want to be notified because I can see what it's doing here. But those are just the design choices that I've done when developing it. And at the end, this is what the script does. So another script here for the Argos, and this is really brief introduction to Argos itself. Argos is a framework, as I mentioned, and it's responsible for this little icon here. Argos works with any executable. In this case, I chose Python. You can see in the file name, we have here 2s, which stands for 2 seconds. This is how often Argos will refresh a certain file. And we're not going to go through this, but that essentially tells Argos to read the content of a temp directory for specific files. And then if file is found, then it updates this graphical interface here. And what I always like to do, I like to add documentation to projects, especially that are a little bit bigger like this one. And this is documentation in my Obsidian repository. So those are all the project files. Okay, so now let's actually see this in action. So I am going to start 2 Claude sessions, and you can see both of them are starting with this monitor. So it tells me session poke window 3 pane 1, and here it tells me session the same poke window 2 pane 1. And now I want to essentially demo how these notifications would work. So here I can say check whether using curl in London. That's not a grammatically correct sentence, but let's see if it can do this. I will hit enter and I will swap to another Claude session. So we are off this session, and you can see now I have this red icon. It's changed, and I have my shortcut set to Ctrl-Alt-Shift-Z, and then I can go back, and indeed Claude is waiting for me to confirm and actually execute this weather. Let's see what's weather in London. So 16 degrees Celsius, quite good weather for London, especially this time. All right, so that could be one idea. And in this session, we can, for example, say write long lorem ipsum. And we can again swap somewhere else outside of this specific session. I am currently in one session, but I could swap completely to different sessions. So I could, for example, do this back to our demo or back to our slides. And at some point when Claude is ready with writing everything, we would see a red notification here. So I don't need to look at this session. I can go and do something else, and Claude would automatically notify me that it's ready with the output. Okay, so let's swap to YouTube main, to our slides. So what are the highlights of this setup? So first of all, we've used open source tools. All of those tools are freely available. They happen to be on Linux. That's the system I am using. I'm using PopOS, but there are equivalents of those tools on Mac and other systems as well. We used file system as a messaging queue. That's very important distinction. So we produce files every time Claude gives us a message we want to detect. And then we have a distributed system with decoupled components, thanks to this idea of using file systems. So a little bit of documentation. You can read about Tmax, Argos if you're interested, and Unix philosophy is also very well documented. So I showed this as an example of using Claude in my case, but you can imagine doing this with anything. So it requires Tmax, but otherwise, once you have Tmax, you don't have to use Argos. You can use actual notification or don't notify at all, just execute a bash script if you detect something. So this adds kind of a really interesting layer of interactivity to your systems. All right, so that's all for today. I hope you've learned something. I realized that this is a very kind of bespoke workflow, and it touches quite a few areas. So let me quickly summarize what we've done. We've looked at the problem of detecting text using regex patterns and reacting on this text in a Tmax pane. We talked extensively about distributed systems and made parallels between using Linux and its commands and Unix philosophy and distributed systems. So kind of bridging the gap between cloud computing and your local system. Having an elegant architecture that solves our current problem, and it's extensible and relies on file system as a binding mechanism for our inputs and outputs. Let me know what you think. This is, as always, available in my .dot files if you want to adapt it to using Claude or any other AI with a few tweaks. I hope I inspired you to think about your own system that you can build yourself for detecting various text patterns and reacting for them. And yeah, let me know in the comments what you've built, or maybe you already have a system that you're using. I would be interested in that. And I still want to see what happened here with Claude. So, oh, it's an error. Okay. So content filtering policy. Apparently, you cannot write lorem ipsum. Oh well. Because our notification didn't trigger. I wasn't sure what happened, but that's about it. So once again, thanks for watching, and as always, see you in next video.